Right, so I'm recording now. So I think so the project is called The Origins of the Universe, and I think essentially for me, I think one of the questions when I was trying to ask other people what is what are their interests of the origins of the universe, most people completely draw blank. They don't even seem to consider that um in in a way that's practical and say, okay, this is actually meaningful. So I guess the first question I'd ask is, why is it important that we understand the origin of the universe? Um, and yeah, and that's probably the start of my questions.
Well, there's several answers to that. Of course, if your question is, how you're going to feed your kids tomorrow, or you know, how you're going to keep your girlfriend or whatever mad from being mad at you, it doesn't matter at all. However, with that said, if you look at the oldest writings that have ever been made, they are questions about precisely that. How did we come into existence? I mean, these are timeless questions. People have been paying attention to them for thousands of years. They used to be the providence of theology and then philosophy. But in the last 100 years or so, we actually have made some real scientific process or progress. We really do have a pretty good idea of how the universe came into existence. We don't know everything, but we know a lot. So it's important because it seems to be very crucial to part of what it makes us to be human. And this is a good time to actually ask the question because it's not a matter of just guessing anymore. We really know quite a bit.
Okay, so I guess I'll then go on to say, like, how is it that we know, or what is it that we know, I guess, and then probably next is like, how do we know that? But what is it that we know? Like, how old is the universe for us, I guess, because depending on where we're looking, different things are happening at different times. I'm kind of jumping ahead there, but how old is the universe, or how old do we see it as, and how do we know that kind of stuff?
Well, as it happens, earlier today I was writing. I do these great courses, and so I was writing a lecture on precisely this. So,
Sweet.
according to the best knowledge that we have, the universe is the spectacularly precise 13.799 plus or minus 0.021 billion years old. So it's about 13 billion 800 million years old, plus or minus 20 million. So that's ridiculously precise when you think about just how accurate that is.
Yeah.
And so how do we know that? Well, that is a lot harder because there's a lot that goes into it. So I don't know how much you know about this, but of course you know the universe is it exploded, and that's a little inaccurate. People always get the Big Bang wrong. I'm sure that as you go into this, it'll take a while for you to get your head around it. The Big
Okay.
Bang
Cool.
the Big Bang was not like a firecracker or a grenade. It wasn't sitting there and it exploded. What happened was the universe was sitting there and it started to expand. Now that's different. So you think about this: if you have the universe and there's uh, I don't know, firecracker or a grenade right here, and it explodes, what will happen is a sphere will grow in this space that already exists. But the Big Bang says that's not the case. It says that everything was here, and then all of space and all of matter expanded together. So it's not like space existed and something blew up inside it. It's just like like a rubber band or something. All of the universe was a dot on the rubber band, and the Big Bang is when you stretched it. That dot went from being a little dot to being like a line as you stretch it out. So
Okay.
that's
So in that way, would you say, is it like the assumption is that the universe always existed, and then that the beginning of the universe is just the point when it started doing that? Um,
well, truthfully and honestly, nobody really knows. I mean,
okay.
if you look at general relativity, which is the sort of basic idea, is that the meaning of space and the meaning of time didn't mean anything because everything was compacted into a single spot. And it's only when the expansion occurred that time even became a thing. Before that, there was no such thing as time, which is really hard to get your head around, how time can like not be. But
Yeah.
that's what it says.
Yeah.
Most people, or I should say most science people, know that this is wrong. And the reason is that general relativity, while being a brilliant theory, it applies only to certain regions. It applies here on Earth, it applies to the universe, it applies to black holes. But what it doesn't apply to is the very small. So if you take the equations of general relativity and you squish them and make them, talk about something that's smaller and smaller and smaller, eventually the theory starts predicting infinities. And when a theory starts predicting infinities, it means it's wrong. It means that you have pushed it too hard. So what the problem is, though, then, is nobody has a better theory for what happens to gravity when things are very small. So at the very moment, the universe started expanding. We don't understand why. As it expanded, it got bigger. And sometime in that expansion, it got big enough that general relativity was okay. And then it applied from there and forever. But before that time, we literally don't have a theory for what happened at the moment. So we can't say whether or not the universe existed forever or it didn't, because even in general relativity, time doesn't matter. But that shouldn't be important because we know that the theory doesn't even work for these early moments. So, anybody who tells you that they understand truly the moment of creation either is lying to you, doesn't understand it, or they're telling you something about general relativity, but general relativity isn't the same as what truly happened. General relativity is a theory, and what happened is what happened.
Yeah.
So,
Okay.
you talk to someone like Brian Greene or one of these I guess Brian Greene's not a theory type, but you talk about,
Who's
to one,
sorry, who's Brian Greene?
and I meant Brian Cox. Brian Greene is a
Oh, okay.
theorist.
Yeah.
Brian Greene is he is a theoretical physicist at Columbia, but I meant Cox because
Okay, cool.
he's
Brian
in the
Cox.
UK. Yeah.
Oh, yeah,
But,
yeah.
but of course, Cox is like one of me. So in all cases, I was wrong. So,
Yeah.
so you talk to DeGrasse Tyson or something like that,
Yeah.
or for that matter, when Hawking was alive, if you talk to him, he would say, "Well, this is what happened." But what he's really telling you is what the math says. But we know the math breaks.
Yeah.
And so you need to be aware of that. If anyone tells you about a singularity, if they tell you about the absolute moment of Big Bang, if they tell you anything about that, they either don't know what they're talking about, or if they do know what they're talking about, they're assuming you don't know what you're talking about, and they're going to just tell you the math.
Okay, cool. Okay. So it's